Greetings and welcome to another Re-Unblock screencast. In this screencast we're going to continue our journey to learn about CosmWasm, and we're going to be continuing to use the CosmWasm book as shown here. And in this video we're going to look at the chapters for creating a query and testing a query. So without further ado, let's proceed. Right, I'm going to add a couple more dependencies to our package. I'm not going to use the same dependencies as stated in the book. I'm going to use the latest. So for this surd, it's this. So I just replace this with this. And for the multi-test, it's this. I'll just replace that with this. And move on. So it suggests here in the book that we add a new entry point to this code, and we import or use the surd library here. So let's copy this into our contract, and I will put the use statement at the top. So we've got the instantiate function, and then we got this struct, this query response that has a message attribute, and the query entry point, which takes the dependencies and the environment and the message, and just returns this hello world. So the reason why here we use this module here is this object, the depths object, is because here in this query we are unable to mutate this particular object. Another thing that's missing or that is different in the interface of this query function is there is no info object. And let me just remind you what that is inside here. I'm referring to this. This message info or info object here is not included in the query. And this is really because this contains information about who called the function, but in here it's a view function essentially that we don't have to behave differently depending on the caller. And finally, in this query object we are returning a arbitrary serializable object rather than the response type, because queries are not designed to work with the actor model message flow. In other words, they can't trigger actions or communicate with other contracts in another way. They just are for this. This is really just for querying the contract and returning the data for the caller to display. So there is some refactoring that we can do here. So we have a query, but it's always going to be returning an empty JSON. And if we wanted to add a different type of query in the future, it'd be difficult to have a reasonable distinction between these two types. So we can do this by improving our contract like so, using an enumerable or an enum type, which is the query message. And this is what we're going to be passing into the function. And then we use a match statement to check the contents of this message. And if it is an empty message, then we're going to build this query response that we want to send back and build it up like so with just a simple hello world statement, and then serialize it as binary. So we serialize this response as binary, and that's what we can return as a standard result. So let's copy that in to our code. So we've got the query response and the query message, and now we have a specific type of thing for the query message and a specific type for the query response. Now I'm still getting this error here. I'm going to figure that out in a second. So we performed some refactoring on this contract now, and what we end up with is 3 files: MSG, librs, and contract.rs. In the MSG file, this is where we're storing the definition, the data types if you like, as well as the serialization logic. I say logic, but really we're just bringing in this library and bringing in the serialize and deserialize modules there, or traits I should say. And the traits are then applied as attributes to the struct and to the enum, such that if we want to serialize or deserialize them, we can, basically, thanks to this library. Now, the greet response has a public attribute called message, which is a string, and the query message is just a single trait called greet, which basically has a empty object there. So in the library, or librs, this is another file which is pretty straightforward and very direct to what it does. Essentially, it manages all the module imports or use statements here. So we're importing all of the CosmWasm STT or all of these specific types inside the CosmWasm STT. We're also bringing in the modules for contract and MSG. So that's the module here and the module here that we just looked at. And then we're defining two entry points. So essentially what this is doing is, this is a file which is the public API of our contract. And so it's a nice way of just having the API that we can see, and then it just calls out to the contract functions accordingly. So we can see there's two entry points, the instantiate function and the query function. And the query function is what we're going to be really testing and using most. The query function, when called, will pass that to the contract query function and just forward all the variables onto that function there. So that function is defined in contract. So contract has these dependencies here. Okay, so yeah, so we're bringing in the message types here from the dependency here. We're defining instantiate, which doesn't do anything at this point, but the query function is defined, which basically takes the message and on the match will call this, and this 2JSON binary is part of the CosmWasm STD, but it will pass that, or basically call the query greet function here in this module that's defined down here. And all this does at the moment is just returns hello world. So it doesn't take any parameters. Maybe it could take the name of the person or whatever to return something different. But for now, that's what this returns, is this result, which is this greet response. And it has one attribute message, and it's always going to be okay, which we'll come back to here and serialize it to JSON binary. And remember, this is serializable, so we should be all good. Now, this does actually build as well. I can run CosmWasm and it builds okay. So the next thing we want to do with this is start to write some tests. So we've written tests before, and when we've built standard core Rust contracts, or Rust applications, I should say. Now let's drop this code into here. This is the test code. And let's see what we can do here. Now we've got run tests, but we've got some issue here. It's binary operation cannot be applied to message. Okay, so according to the book, the reason for this error message in our test that we saw is because we need to add some more derives to both of the message types. And particularly we need to add partial, equal and debug to support the testing environment, because partial equal is needed to compare the two messages, and debug is used by assert equal macro. So I can just copy this and put that into here. Okay, I don't need to copy that again. Okay, so now that we've got that copied in, we should be able to come back here, and yay, our errors have gone away. Now we can run the tests. So we clear the screen, cargo test. Let's expand this out. And it worked. Great. So let's just review that. We've got a test here that basically is going to call query greet unwrap. So remember, unwrap is going to basically unwrap the response to the actual value, which is going to be this. this RESP, and then the response should be the same as this. Basically, it should be this type with this attribute with this data or this string. So if I change this to S, we can see this probably will fail. Right, left is not equal to right, and so yeah, it's really working. Cool. We've refactored our test a little bit here because what we want to do is try to test our smart contracts in a way that they would be used by callers and users of the blockchain, right? So we've got to start to put our blockchain hats on and start to think, how is this going to be called? So in the previous test, we were really testing from the inside out, if you think about it. And what we really want to do is treat this as a black box contract and call it from the interface. So what we can do here in order to do this is to call the greet query function directly, or I should say the query function directly. So let me just scroll up. This function here, which is the public function, so you can think about this as being the interface on the contract. In fact, it's called through this here, this entry point. So really what we want to do is test this entry point. We want to test the contract through the entry points like this, right? So in order to do that, we need to refactor our contract test here. And in order to call this, we need to bring in some mock dependencies. So if we look at the interface of the query function, you can see that it takes this deps, the env, and the query message. So scrolling back down again, we are mocking the dependencies as a reference. This as a reference because we're not going to be modifying this. We're going to mock the entire environment because we don't need to, we're not working with the environment in this particular function anyway. The only thing that this function uses internally is the message. So that's the only thing that we set here, which is our greet variant that we want to pass in here. And so we call the query function with these parameters. Two of them are mocked, one of them is our greet. So if we pass that into this function here, then it's going to match this, which we'll call this to JSON binary, which we'll call this greet here, and so on and so forth. So once that greet has executed, it will return this OK result type, which is going to be this std result. And so when we unwrap, it's going to unwrap that to this here, this response variable that we have defined here, which will be of type greet response because it would have been deserialized. And now we can deserialize it using this from JSON, taking the reference of the response object that we get back here, unwrap it, and then check that it indeed matches. So that was a minor refactoring, going from testing inside out to testing more of the interface. But there's still one other thing that we haven't done, which is instantiating the contract. So interestingly, of course, again, because this is Rust, and we're only testing Rust at the moment, we're not really deploying this and running this on a blockchain. We're able to, that's how we're able to do this. Whereas, of course, if we're testing Solidity contracts, we typically will use Foundry, and Foundry will deploy those contracts to a local EVM, which will then require all the necessary things to be set up in order to run the tests. But here, because we're testing using pure Rust, we can bypass a lot of these things and just test things without really having to worry about the blockchain. That can lead to some issues, I suspect, but I'm sure that there are ways to run these tests on a blockchain. But the next refactoring is essentially to bring in this instantiate method. So let's copy and paste this test section here. So the refactoring that's happened here in this test is basically that we are now calling instantiate here, and we are then calling the query. The main thing to note is that we have extracted out the depths and the environment variables here and here to get the to be able to basically pass the same instances of these variables to the instantiate and to the query function call. This is because these variables are basically related to the underlying blockchain, and so they need to be connected to each other when calling instantiate and when calling query, so that we don't have to have any disparity between the two calls. The other thing to note is there is the info that's included in instantiate. Remember, this is message info that includes details about the sender and their funds. So this is essentially the same as message.sender, message.value in Solidity, and we're calling this with a mock info object. Obviously, again, a very handy way to mock this sender when we're writing tests like this. So this is more of a black box approach where we're able to instantiate and call a query function. That concludes this screencast on creating and testing queries in CosmWasm Rust-based smart contracts. I hope you enjoyed the video, and I'll see you in the next.